Today, we are talking about loops. A loop is an action which is performed repeatedly and depending on various conditions, it can be performed several times. Java allows looping of 4 types, and each of them is designed for a different purpose. It will be best to skip the theory and get right to the practice. Run the IDE, create a new project, loop. Create a new class and call it loop as well. Create a program entry point. But before we start, let's take a look at 2 operations we haven't yet studied. It is high time we did it. Let's create a variable int a and assign it the value of 10. How many ways of increasing its value by 1 do you remember? The first one is to assign it +1. The second way is a shorter way of the same operation, a plus equals 1. These are the ways you already know, but there is a third one we have not yet discussed, but it's very common for looping. It's called increment operator and is written thus, a++. This operation is called increment operation. It increases the value of a variable by 1 and assigns this new value to the same variable. Similarly, you can decrease the value of a variable by 1. We already know such ways of doing it. A assign -1 and a shorter form of the same expression, a minus equals 1. But there is one more way, which is new to us. It is called decrement operation, and it's written thus, a minus minus. So we are all set. Let's try looping. So the task is as follows. You must print out numbers from 1 to 1000, each one from a new line. If you decide to rely on only what we've learned to complete this task, you would have to write such a construction 1,000 times, putting a new number on every new line. To abstain from such a perversion, you can use loops. The first loop we will study is called while loop. It's written like that, while, specify the condition in round brackets, and then place the needed code into the curly brackets. It looks very much like if construction, with the key difference that if construction will perform the code in the curly brackets only once, whereas while will do this continuously unless the condition ceases to apply. In this case, we want to print numbers from 1 to 1000. Let's create a variable to be printed out. Call it I and assign it the initial value of 1. Now specify the condition. We will perform the action until I is less or equals 1000. In this case, we want to print the value of the variable on the console, so in the code block, type sout I. After this, we need to increase the value of I by 1, I++. So what is to be happening? The program creates a variable and assigns it the value of 1, then checks if 1 is less than 1000. Yes, it is. It means that the code must be run. It prints out our variable, which at this time equals 1, so you will see 1 on the console. Next, variable I will be assigned the value of 2, because it will be increased by 1. The condition is checked again. Is 2 less than 1000? Yes, it is. The code is run again and again, until I is finally equal to 1000. When I equals 1000, the code block prints the value of the variable on the console, adds 1, and the value of I becomes 1001. The condition is checked again. Is 1001 less or equal to 1000? No, it isn't. The code block is skipped and the program keeps running. Let's run the program and see the result. The numbers are being printed. Now let's imagine we have forgotten to add the increment operation. Run the program once again. Our program will endlessly print out ones unless we terminate it manually. Why is it happening so? Because in this case, I equals 1, and the loop checks if I is less than 1000. Yes, it is, so it prints out 1. After this, I retains its value of 1. The loop rechecks, is 1 less than 1000? Yes, it is, and so on infinitely many times. Let's get the increment operation back. At any moment, we can terminate the loop by the keyword break. We can interrupt the loop execution when a certain condition is reached. For example, let's break the loop when I equals 5. If I equals 5, break. Run the program and you can see that it has printed out numbers from 1 to 4, because initially I equaled 1 and the 1 was printed out. Then the value turned to be 2, so 2 was displayed. Then 3 and so on. The last printed out number was 4. After that, the value reached 5. The conditional test of whether I equals 5 returned true, and the loop was broken. Now here is a task. Try to apply your knowledge on int type, conditional operator if, and loops to print all even numbers from 1000 to 0. I'll allow you several seconds to pause the playback of this video. Good luck! So I hope you have completed the task. Let's delete all this code. First of all, let's create a variable and assign it a value of 1000. Int I equals 1000. Since this variable is a counter, and it's common to call such variables I, we've called it I. In this case, we want to print out numbers from 1000 to 0, which means that we must perform the actions while the value of I is either more than 0 or equals it. We will only print even numbers. To find out if the number is even or odd, we can use the percent operator, which shows the remainder in division. Type if I percent 2, which means if the remainder in division of I by 2 equals 0, that is, the number is even. We must print it out without I. It means that if the number is odd, the remainder in division by 2 will equal 1, and we will not print it out. After that, we must decrease the value of the counter by 1. It's a decrement operation. Run the program and see what is supposed to be printed out is printed out. Only the even numbers from 1000 to 0. Here is another task, a little more complicated this time. Write a program which calculates the arithmetic mean of all numbers between 0 and 100. Before watching the solution, try to write the code on your own. If you remember to calculate the arithmetic mean of numbers from 0 to 100, all the numbers must be added up to each other, and the result must be divided by the quantity of the numbers, that is by 100. I'll allow you some time to pause the playback. Good luck! Here is the solution. Let's first delete this code. Create two variables. One of them will store the sum total, and so we'll call it sum. Its initial value will be 0. Another one will store the quantity of the numbers, so let's call it count and assign it the value of 0 too. We must also create a third variable and call it result. It will store the result of the calculations. The arithmetic mean may be a non-integral number, and so its data type will be float. Float result. Assign. In order to find the solution, we must divide the sum of the numbers by their quantity. Semicolon. In this case, both variables are int type, but the result must be float. To achieve this, any of the variables must be recast to the float type. Let's do the casting. we will recast variable count to float type, which means the result will be float type. And we'll need to print result on the console. Now let's create the loop itself. Type while until the quantity of numbers will be equal to 100. Let the counter start with 1, not with 0. So what is to be done? Each variable must be added to variable sum, and then variable sum must be increased by 1. It sounds like a plan. Type sum plus equals count. And now increase the value of variable count by 1. Count plus plus. In this case, count equals 1. Let's check that count. The action must be performed until this variable is either less or equals 100. Then we increase sum by 1 and increase count by 1 as well. Variable count then equals to 2. The condition checks, is 2 less than 100? Yes, it is. Now sum equals 1. We increase it by 2, so sum is now equal to 3, and so on. Thus, we have calculated the sum of all numbers from 1 to 100 and found out their quantity, which eventually equals 100. Then assign the following value to variable result, sum of the numbers divided by their quantity. Print the result on the console. Let's run the code. Provided that everything is done correctly, the result will be 50. Well done. Let's continue with looping. We will delete all this code and write a new loop. Create variable a and assign it the value of 0. Create such a loop. While a is more than 0, print the word high on the console. Run the program. Nothing is printed out. It happened because the condition never applies, as the variable is always equal to 0. But what if we want the message high to be displayed at least once, even if the condition does not apply? It can be done, for example, this way. Copy this line and place it outside the loop. In this case, it'll be printed once, and then condition will be checked. This is called code duplication. The same code is used more than once. This practice is strongly discouraged. There's a special kind of loop just for this. It's called do while. Its only difference from while is that it runs the code block within curly brackets and only then checks the condition. The syntax is as follows. Type do, specify the action to be performed within the curly brackets, and after this, type while and the conditional test. Don't forget about the semicolon. We will delete the previous while loop and also this line which prints out high, and run the program. As you can see, regardless of the fact that the condition does not apply, high is displayed. The only difference of do while loop from while loop is that the code block will be run at least once, regardless of whether the condition applies. There are no other differences from the while loop, so we will not study this one in more detail. As I have told you, there are 4 types of loops, but today we're going to learn only 3 of them. In order to study the 4th one, you must understand what arrays and collections are. Once we have studied them, we will learn the last type of loops too. And here is the 3rd type. It's called for loop, and the syntax is such. The loop is best in case an operation is to be performed several times. In our first program, we used while cycle for that. But it's most often used when a condition is to be checked, that is, while the program is still running, while the file has some data, and so on. But if you need an action to be performed several given number of times, it's best to use for loop. Its syntax is as follows. For, a counter variable in the round brackets, a condition which must apply, And finally, an action which will be performed once the code block has been executed. It's most often an increment or decrement operation. In this case, we have created a variable, assigned it a value of 0, and gave an instruction for the loop to be run while I is less than 100. The program, while the condition applies, and in this case it applies, will execute the code block which will be specified here. Once the code block has been executed, variable I will be increased by 1. Let's just display the value of variable I. Run the program and see that we have all the numbers from 0 to 100 displayed, but not 100 itself, as we have written less. Let's apply this loop to display even numbers. Let's print out all numbers from 1000 to 0, which are divided by 3 without remainder. Let's delete this code and write a new one. For int I, since we will print out values from 1000 to 0, let's initially assign variable I the value of 1000. Let's execute while I is more than 0. After executing the code block, we must decrease the value of I by 1. Now in case I is divided by 3 without a remainder, we must print it on the console. Create a condition if I%3. That is the remainder in division of I by 3 equals 0, which means it's divided without a remainder. Then print out I on the console. Run the program and see that all the numbers that are divided by 3 have been displayed. So our lesson is over. And here's your homework. Create a loop which prints out all odd numbers in the range of 100 through 1000 inclusively. That can be divided by 5 without a remainder. Good luck! See you in our next lesson.